Hi, thanks for watching my presentation today. So I'm going to talk about some small scale tests we did at the Forest Products Laboratory, and this was looking at adhesive performance under fire situations, elevated temperature for CLT. So CLT, or cross-laminated timber, is a type of mass timber composite. So mass timber, there's kind of been a revolution of mass timber use in the United States. I have another talk about that in North America, but it's a class of wood composites that includes cross-laminated timber, or CLT. So those are big panels that come with dimensional lumber glued together in alternating layers, and they can come to the job site with doors and windows pre-cut. So that's kind of what's on the ceiling in this picture here on the left. And then it includes glue laminated timber, laminated veneer lumber, other types of structural composite lumber. And so these massive wood composites have allowed us to build a very tall wood buildings. So this picture on the left here is a picture of an 8-story building in the United States, the Carbon 12 building. And you can see it's got glue laminated columns and CLT ceiling. And this is great. This is exciting. It allows us to build more sustainable buildings and use low value timber in these very high value projects. And so one question as we're coming into code adoption in the United States is, how does mass timber perform under fire? So you can see in this Carbon 12 building, there's a lot of exposed CLT, exposed glue lam, and we know that we understand how wood chars, that's very clear. But CLT and glue lam in these things have adhesive layers between each of these solid wood things. And so the adhesive performance determines a lot of the fire performance of the engineered wood product. And so in some early large-scale tests on CLT, this is from the Fire Protection Research Foundation tests. They built some CLT compartments, and then they had various levels of opening, various levels of gypsum board encapsulation on the CLT. So you can see this test 1-1. This was fully protected by gypsum, and test 1-5 had some exposed CLT, and you can see that in the beginning you have flashover and everything's kind of the same. But then as the compartment's starting to cool down, in this test 1-5, some of the CLT falls off. One of the layers falls off before the char front reaches it, and that introduced more fuel to the room, which then caused a secondary flashover fire regrowth. And so that fresh fuel on the clean CLT surface and the lumber that dropped into the room causes the secondary flashover. And so understanding why this secondary flashover occurs and how it can be prevented is very important, and that depends upon the adhesives. So instead of building these full compartment tests, we've been building small scale tests that will help us predict whether or not delamination can happen. And so in the United States, currently, to get your product qualified for use, you need to pass this PRG 320 test, where you build a compartment essentially like what's in that Fire Protection Research Foundation test. And then you apply this temperature profile here, which is basically taken from the FPRF test. And you have to make sure that you do not have any temperature increase in this last 150 minutes here, when the heat release rate from the burner is very small. And so you can see some results from that test over here, and you can see that one of these polyurethane adhesives delaminates, and this delaminates again about here. So that would fail, but the melamine formaldehyde and second PUR adhesive, both in blue, passed this full-scale test. So we've developed a small scale test that has a single lab shear joint. It's in a temperature controlled chamber, and we are applying a fixed load, and it's very similar to what you would observe in service. And we're seeing good correlation between our small scale results and the field results. Thank you so much.